Thanks for the opportunity. I'm going to talk about the work that the Energy Center is the CSI are currently doing in the sustainable development for the energy sector. Good. So my talk talks about the Energy Center, and then I will give you some case studies, some projects that we currently involved in solar photovoltaic quality and reliability infrastructure, and some work that we have done on and currently also doing around strategic wind resource assessment, and of course, just energy transition. And I will end my presentation by talking about the collaboration that we have across different sectors for industry development and some of the contract R&D clients that we are currently working with. The CSI Energy Center is currently structured across the energy value chain. We've got two research groups focusing on technology. One research group who is focusing on system approach, and the other one is end user facing. So in the first research group, which is the energy supply and demand, we do research on demand side management, where we focus on energy efficiency and demand side management, demand response. The other focus area under this research group is quantifying the energy resources, mainly renewable energy, wind and solar, where we are trying to quantify and advise end users as well as the policymakers. We also work around renewable energy technologies, mainly PV, solar, and wind. We also focus on thermal energy storage as well as waste heat recovery, some technology development. Currently, we moved into the hydrogen economy, where the country is mainly focusing on hydrogen activities. So we've got some activities happening in that area, mainly around techno-economic analysis, just to advise which pathways to follow for hydrogen development in the country. So the second technology-focused research group that we have is electrochemical energy technologies, where we have been developing for a number of years battery materials and devices, fuel cells, as well as supercapacitors. The system-focused research group, which is called the Energy Systems, where we focus in energy modeling for the countrywide, like integrated resource planning type, as well as provincial and municipal type work, where we do energy master planning to support municipalities with the energy transitions. We also do research around energy system designs, energy system operation, mainly around grid optimization. The end user focused research group, which is called Energy Industry, we have research focusing on industrial support, socioeconomic analysis, techno-economics, small medium enterprise development, and as well as just energy transition. So we also have another program which cuts across, where we do real-world implementation research programs, where we test, develop, and prototype and field deploy some of innovative energy storage solutions. So one of the major flagship project that we have within the Energy Center, where we used public funding to develop the infrastructure and the human capital required, is called Solar Photovoltaic Quality and Reliability Lab. It's ISO 17025 accredited photovoltaic lab, where we are trying to support the growing PV industry with quality and reliability. The big infrastructure that you see in the middle is like Sunshine in a box. It's called Sun Simulator. It's got an attachment on the right-hand side of the screen, where you can vary the temperature and do some analysis on solar PV modules. We also got some environmental chambers, specifically thermal cycling and humidity freeze chambers, as well as damp heat chambers, where we provoke, we mimic the failures that these modules could have faced, during their 25 years lifetime in the field. We also have got a mechanical load tester, which mimics some of the wind load that exert into these PV modules where they are implemented in the field. So we do optical and electrical analysis on these modules, and then that information will feed into informing how good quality and how reliable the PV modules are. In fact, in these three pieces of equipment, we got a public funding from DSI through the Technology Localization and Implementation Unit, which we are using to perform the quality and performance degradation studies on these PV modules. So what we basically do is we assess the relative reliability of different PV modules. We on the left-hand side, we've got a control module, and on the other test sequences, we really exert different type of environmental conditions where we degrade these modules and study and test whether these modules are reliable over the lifetime or as per the specs given by the manufacturers and technology developers. So this is one of the first pilot project that we have done. It is a 4-month study. It's very exhaustive, but it gave us very good information about locally assembled modules as well as, commercially available imported modules when it comes to the electrical performance over some of the environmental stress that we applied in the laboratory. So some of the modules degrade more than 5%, so that means they will not stay in the field as they claim that they're going to work for the next 25 years. So these are the type of study that we are doing, informing the PV industry as well as users and of course decision makers. So in the CSIR, we are converting the CSR into sustainable campus. We spearhead a program, energy autonomous program over the time. We named it even smart utility programs, where we assisted the CSR in implementing more than 2 megawatts of PV. At the moment, we are producing about 14% or so of our energy ourselves and consume it within the CSR. So we've got different configuration of modules where we used it, to research and inform, the users which type of configurations to use, be it single axis tracker, dual axis tracker, east-west facing modules, or is it the usual north-facing modules? So these are the type of research that we're doing, and knowledge that we generate here, of course, feed into the public. So we used the public funding to develop service offering around solar photovoltaic. Of course, there's some of the testing services that we provide, electrical performance testing, across different temperatures versus different temperatures and irradiance setting. We also do accelerated stress testing. We do safety testing. This is very, very important. And we do some optical and electrical measurements. We're also developing some technologies for solar cells defect using the machine learning models. So one may ask, when do I really use your services? You need our services when you do module selection and procurement stages, when you do pre-construction testing, when you do annual degradation monitoring. Of course, this is for claiming some of the gains. And of course, sometimes these modules fail and you need some warranty claims. So you need to justify the claims that time. You definitely need our services. And of course, when you encounter underperforming PV plants and when you would like to troubleshoot. So the other very important project, very impactful project, in my opinion, that the CSI has done for the past 12 or so years is around strategic wind resource assessment. Before this program started, Wind Atlas for South Africa, many people think the wind resource in the country is not that good to really make use of it. Then, a few years later, the CSI produced high-quality wind atlas in collaboration with Danish Technical University and other partners from UCT, SANED, and others. If you start the journey, when we started, the first attempt was done in the late 1990s. As you can see, on the left, right screen, this measurement, this graph, this class was developed using a data that was collected at 10 meters, and it really, it doesn't really show the true value of wind. There were some attempts following Diaby's study in 2001 and 2008, but the measurements were not done at hub height where you normally put these wind turbines. But now, thank goodness to the WASA program, that program really assisted us to put together a very good, high-quality wind atlas for the country. And this data is also used in a very important study where we conducted wind and solar aggregation study. Not only that, if you go into page 13 of our IRP 2019, it's clearly stated there the wind atlas developed for South Africa provided basis for the quantification of the potential of wind in the country, especially in western and eastern part of the country. If you compare these two graphs, the top one is where currently wind and solar renewable energy projects have been developed. And if you can see the blue, it really matches with where we have very, very good resource. Really, this wind map assisted in the buzz of the growing wind industry in South Africa by pointing how good resources are around our coastal regions. Not only that, the data that we produced assisted in identifying renewable energy development zone and power corridors, which has been used for infrastructure development projects in the country. So that the same data has been used by when ESCOM did a grid planning process, and most of these transmission development plans have taken into consideration the wind data and the distribution of renewable energy power plants, which have been identified through the WASA project, has been well aligned with our current transmission development planning. And of course, if you see between the first bid window and the latest, which was in 2015, you can clearly see the significant reduction in cost for wind power, which was a result of the WASA high quality data informing people where to strategically invest in wind in the country. Not only that, the same study that we have done for the onshore wind, we would like to also explore into the offshore wind space. South Africa has got very good world-class wind resource when it comes to our coastal area and our offshore. So we really want to take this learning into the offshore, and we are partnering with different institutions like the World Bank to quantify, what could be good offshore wind fit South Africa's, to answer some of the questions rather, whether could South African wind fit South Africa's future energy mix of the, theoretical potential that have been identified, quantified out of that 645 gigawatt. What could be some of the technical potential that are feasible, and where should that location be? So these are some of the answers that we would like to answer using some of the public funding that given to us. So in the wind space, of course, we've used the public funding to develop some of the services, know-how that we are providing to the industry around a measurement campaign, We can assist the industry with the measurement using remote sensing LiDAR system for wind measurement. We also can support during the installation and commissioning. We also have got technical capability to do in accordance with international standards to do some data quality and assurance, of course, that is required to unlock some of the potential funding for projects in that later stage. We also have got a capability in operation and maintenance of wind. And of course, across the project life cycle, we've got a capability, expertise, and concept development, measurement, resource modeling, as well as feasibility studies to perform pre-feasibility calculations of your wind projects. The other research that currently growing, where we're trying to support, is around just energy transition. As you know, whatever work that we are doing shouldn't neglect the social, economic, and environmental effect, and only concentrate on technical and cost effects. That's very important as we move into low carbon economy. We need to quantify the jobs that's going to be lost and the jobs that will be created by renewable energy, as well as what are the social and environmental effects that comes with it. So we've got some research institutions and the stakeholders as per each research area for technical, social, environmental, and economic effect. So for industry development, we are collaborating with a number of institutions, with regulatory and standard bodies, with CBs like NERSA. We also collaborate with regional power integration, like Southern African Power Pool, industry associations, SAWIA, and others. Local research institutions, international research institutions, industry, other research councils, and as well as state-owned entities, and of course, with also higher education institutions. Just to show you some of our major clients for the energy center, we getting work and from ESCOM, from DSI, Department of Health, UNISA, SANIDI, DBSA, and UCITA, just to mention a few. We also have got private clients like Energy Partners, SAICA, Souls and Energy, and also we work across many development institutions and foreign institutions such as GIZ, VITO, KfW, Astro Energy, and French Development Agency. At least the key takeaway, as per the request, CSR used the public funding to establish the Energy Center and operate research laboratories specializing in energy and sustainability. And we have got state-of-the-art facilities and experts who conduct research in areas such as solar PV module quality and reliability, remote sensing resource assessment, energy efficiency, and battery technologies and etc. We also often collaborate with universities, research organizations, and industry partners. This partnership normally facilitates knowledge exchange, where we share resources and where we collaboratively tackle into some of the research questions around sustainable energy future. We also participate in international collaborations. Time didn't allow me to mention, but we've got several collaborative projects with different institutions, internationally, across the continent in Africa, Europe, America, and Australia, and even in Asia as well, to address some of these pressing global energy challenges. And this partnership, of course, promotes sharing of best practice and joint research efforts. With that, let me end there, and thank you for listening.
Thank you very much for that interesting presentation. A lot of technical detail because of the nature of the work that the CSR does. It's extremely impressive. And I hope people got the message that CSR is doing critical work and is really essential for the changes that we need to see in the energy sector. We had a discussion forum last month, a 2-day discussion forum on the energy sector, transitions in energy. So please have a look at the website there, all of our participants. Can we have some questions for Dr. Roro? Okay, thank you. Right, an anonymous attendee says, how are research outcomes shared with communities? For example, what examples are there on outreach? Would you like to answer that, Dr. Roro?
Yes, I do. We share, our research outputs through local conferences, through local medias. We share extensively and social medias. That's how we reach social media users. We also work in collaboration with SAICA, where we support small, medium enterprises, and we are also partnering like in institutions such as UCIT, where we train and groom, incubate, entrepreneurs. And that's what comes to mind. But we publicize our work through major platforms that we have at the moment. Thanks.
I found it very interesting what you spoke about in terms of PV solar energy. I suppose it's top of mind for many of us as consumers, because some of us consider putting solar panels on our roofs. Is there a way in which the CSR research informs the consumer? Well, I mean, not directly, but a way in which we can listen to your outcomes and make use of that in considering what type of panels to put up and various factors to make it more efficient.
Yeah, absolutely. I mean, most of our research outputs, we publish them, and you can find in our website as well as in our social media. As soon as we've done a research and a conclusive result is obtained, we publicize extensively using the forum like South African Sustainable Energy Conference, South African Institute of Physics, electrical engineers conferences. Absolutely. Yeah, we are more than happy to help. You can reach us and we can share also some of our research outputs with you if you can find it.
Okay, that would be wonderful. Thank you very much indeed. I hope everyone heard that. You can contact Dr. Roro. You can also just look on the CSR website where there are advisories for the public. Please make use of that. What also struck me was the long term that this kind of research requires. So the work you've been doing on campus, research on solar energy, has been since 2015.
Yes.
Why is that important?
Well, I mean, as you may know, that in order for you to make financial sense, these PV modules have to work for at least 20, if not for 25 years. And, normally in the first or 3 years, you would not see the degradation, some of the faults in your system. They only start manifesting in later days. So, it's a commercial system. So at the moment, what we do is, it was intelligently planned by my colleagues, who spearhead the program. It's a commercial system. At the moment, it's feeding into the CSR system. At the same time, the data that we generate out of the system, we use to do some knowledge generation, information dissemination that we were trying to do. But of course, you need to do research for 20 years at least in order to see whether these modules perform or not. It has to work for 20 years for the system to make financial sense.
I see. That is very interesting. So it means that there has to be capacity at the CSR for 20 years of research on this issue. And
but by virtue of us being a research institution, we have got the privilege of doing research for that long. But it might not be necessary for consumers as long as they put a good quality system up front. I really don't see the problem. But for us, we've got the luxury, and we are every time the data we collect, we publish it.
We were talking about the long-term research and how it's important to research, for example, solar PV over at least 20 years. How do you envisage this research going forward? So obviously, there's still a lot that needs to be done within these 20 years. But can you look further than 20 years to what the CSR will be involved with?
Sure, absolutely. But when it comes to this specifically, the PV module that we installed in our campus, that's what we are talking about. So it's a system that has to operate for the next 20 years in order for it to make financial sense. So most of these PV plants, their lifetime has to be at least 20 years. So now with the newer technologies, the modules become more reliable and can work even up to 30 years at the moment. But 25 years becomes the industry norm. So, but we're collecting the data since 2015, and I hope we're going to continue doing the same, just to inform, how well these systems are performing compared to where we installed them. But absolutely, I don't know what the next 20 years unfold, but the technology is rapidly growing. Modules are becoming bigger. People are coming with innovative ideas. Glass modules, where when they can absorb some of these photons, sunlights in both sides, on top and the bottom. Other innovative materials are being developed at the moment. So number of opportunities are availing themselves, and of course absolutely. But I will foresee PV playing a major role in future, how we use energy in future. At the moment we've got a lot even in the country. Year to year, there is more than 390%, close to 400% growth. Like last year we installed about 1 gigawatt, but this year we installed close to 5 gigawatts. So due to the load shedding challenges that we are having. So, absolutely, these PV systems has to work for the next 20 years. And I'm sure, us playing some kind of role, I don't know in what role, but definitely, of course, monitoring and evaluation, operation and maintenance of these modules, how well they perform over the years, I believe could be one of the area that people will still be interested.
I might have missed something, but is the CSR also looking at the manufacturing of any of the components involved in renewable energy resource exploitation?
Yes. At the moment, in many fronts, one of the area that we working on is on battery materials and devices development, which CSR has been doing for many years. So that's one area that we are developing. In other areas at the moment, we are only 7, 8 years in the making since we re-established the energy center. We consolidated the energy offering in one unit. So, but of course, in hydrogen fuel cell, supercapacitors, and others, I'm sure there are a lot of opportunities that we should be venturing into. But for now, I mean, battery research is one area that we're heavily involved with.